In this video, I'm going to go over how to work with files in C. So files in C work the same as a lot of languages because a lot of languages got how to work with files from C. So with C, we're going to create what are called file handles. And the file handle is basically like a reference to the file. It's basically going to kind of keep a reference to the file. And we're then going to be opening the files. So we're going to be opening the file to access the file. And when we open the file, we open it with a mode. So we open it with a particular mode. And so here I'm going to open the file here. And I'm going to say fh output is equal to fopen. And I'm going to say io.txt. And I'm going to say comma w. So fopen is the function that opens the file and it returns a file handle that we're going to save here into fh output. And file and then star and then the name of some variable here. That's how you can create the file handle variable in terms of declaring it. And this will open it and then return it, and then fh output will be assigned that value. And then the open function, the way it works is it's going to try to open up this file io.txt. Now we're opening it with this w here. So there's different modes you can open a file with. One is W. And the way W works is that it's going to open up the file for writing. So W stands for writing. And we're going to open up the file for writing. Now the way it works is that if io.txt does not exist, then it will actually create it. If it does exist, when we open it up with this mode W here, it will actually delete whatever is in that file and it'll start off with a blank file. So if there was some content in io.txt already, we open it up with the W here, it's going to blow it away. It's going to erase it. And we're basically going to be starting off with a blank file and then writing into the file. Now, when we actually write into the file itself, it works pretty similar to printf. And to be honest, reading from files works similar to Scanf and similar things we can do to read input from the user from the terminal as well. Now, when we do work with files, one thing we're always going to want to do when we're done with them is we're going to say fclose. And we're going to say fh output. And what this does is it basically closes our access to the file. And it says like, we're done with this file here now. Now, to actually put some data in the file, there's a couple functions we could use. I'm going to use this one first. I'm going to say here fputs, and I'm going to say here a string. And then I'm going to say here fh output. And what this function will do is it'll put whatever string we give here into this file here. So we've got enough here that we're creating a file handle. We're opening the file for write access, which is going to create this file if it doesn't exist, or start off with a blank file if it does exist. And then we're going to write the string, a string and a new line to that file. And then we're going to close our access to that file. So let's give this a shot here and just see how it goes. So we run this here and I get no output because I didn't do any output to the terminal. I didn't do any printfs or anything like that. But what I will do is I'm going to say cat io.txt, and cat is a Linux command we can use with a bash shell, and it'll actually output the contents of the file. So I'm just going to use that to quickly kind of show the contents of the file here. So I'm going to say cat io.txt, and it shows us that we have a string in the file, and that's the contents of our file there. And so we've successfully written to that io.txt file. Now we could put other content in the file too. I could say here fputs, and I could say here abc, and I could say fh output, and I could say fputs, and I could say like 1, 2, 3, and I could say fh output. Now when we do this, notice that I haven't put a new line here. So I haven't put a new line on the end of these strings here. So if I were to compile this and run this and then check out our file here, I just get this. I get ABC 1, 2, 3, and then a string next. And it's because there's no new line there. And so if we don't manually put in new lines, then we're just going to be writing as we would to the terminal. Like when we do printf and we output to the terminal, very similar. It's like we have to insert new lines if we want the content to be on a new line in the file. So to do that, I'm going to have to say like /n here. And maybe then I want like ABC 1, 2, 3 on one line and then a string on another. So we decide when there's new lines in our file basically by inserting the new line character. So I'll recompile this, run it, and we get, if I show the file here, we get ABC 1, 2, 3, new line, a string, new line. And so just be aware of that you got to put the new line in manually if you want to. So this is fputs. There's other functions for reading and writing to files. I'm not going to be able to go over all of them in this one video to keep it kind of as a reasonable introduction, but I'm going to say here fprintf, and I'm going to say here fh output, And with fprintf, it works a lot like printf. It's almost identical to printf actually. And what I'm going to say here is I'm going to say data %d/n. So with fprintf, what we can do is we can use placeholders and all the different things from printf in our string here, and then I can provide values for those placeholders. I can't do that with fputs. The way fputs works is you give a string, you give the file handle, it dumps the string into the file. With fprintf though, I can use it basically like printf. The only difference is that I'm going to give as the first argument the file handle of the file that I want to write the content to. And then I give my formatting, then I give my string here that can have placeholders and things like that in it. And then I would want to give the actual placeholder value here. So I could say something like this, I could say 5, or I could say something like this. I could say like int data is equal to 5, and then I could put data here, and that would be okay too. And if we were to compile this and run this and then show our file here, we're going to get ABC123, a string, and then data 5. And so fprintf is another function we've got to write to files. There's others as well that output like a single character to a file too. And one thing I should mention is with fprintf and with fputs, right now we've got the file opened in write mode, but we could open it in a different mode. So we could open it up in this mode here called append. So append mode, the way this is going to work is it's going to open up this file, and it's instead of like deleting the file and blowing away whatever's there and then starting from scratch, it's actually going to append whatever content we write to the existing content of the file. So it's going to append whatever we write to the end of the file. So that's why it's append mode. So we can say we do a recompile here. Now we're doing it with append mode. So I'm going to run this ./d here. Now I'm going to say, let's get the file output here. And oh, I'm surprised actually. I didn't save it, I don't think. I don't think I saved the file. Okay, so I compile it again. I'll run it again, and let's see here. Okay, there it is there. So we get like, there's the first 3 lines, and then we got another 3 lines, right? If I ran the program again, it's going to add 3 more lines to the file, and now there's 3 more there, right? I can run it twice more, do another concatenation there, and now it's in there like an additional 2 more times, right? And so append, the way it's going to work is it's going to take the existing content of the file, and it's just going to append onto it. So just be aware of that distinction between write mode and append mode. Append appends to the end of the file, write will blow away the existing content and start with a new file. So we can write all kinds of things to files. Like one thing that might be common is to have a loop that outputs like a set of data to a file. So maybe we've got data in an array, or maybe we're generating some kind of data and we want to output it to the file. And we can do things like that. So we could say like for int I is equal to 0, we could say I is less than 10, I++, and we could fprintf the value of I to the file. So I could say like fprintf, I'd say fh output, and I'll say here %d/n, and I'll output I, and this will give us the values 0 to 9 in the file. And I've got it back to write mode now, so it's gonna start off with a blank file now when I do a run of it here. So I'll do this and I'll say cat io.txt, and we get 0 to 9 there now. And so you can do this as well. You can have fprintfs in a loop, and you can have that kind of logic. You could even do things like ask the user for some indefinite amount of data, and as the user enters data, output it to the file. So we could do a loop like this. I'll actually include stdbool.h, just that way I can do an indefinite loop using while true. So I can just say here like while true, and true comes from that stdbool library that I just included. Just allows us to use Boolean values like this that look nicer than while 1. And what I'll say is I'll say printf enter number -1 quits. So -1 to quit. And we're going to say here scanf, and we'll read in a number from the user, and we're going to store it into a variable. So I'm going to make a variable here called input, and I'm going to store whatever the user enters into that input variable. And I'm going to say if input is equal to -1, that means the user wants to quit, so break out of the loop. Otherwise, this loop is going to go on forever and ever, and I'll just keep on writing whatever number the user inputs into the file. So that way I can, have some indefinite amount, some unknown amount of data written to the file based on how much data the user wants to input. And so this program here will just, keep asking the user for a number use scanf to get that number and stores it in the input variable here. And if they ever enter -1, we break out of the loop and we close the file and we're done. Otherwise, we just keep writing that to the file here, and we're just going to keep writing it with a number and a new line again and again. So we'll give this a try here, and we'll compile it here. We'll run it here, and I'll say here like 4, 9, 12, 2, 8, 10, and then -1 to quit. And then if we look at our file here, we're going to have 4, 9, 12, 8, 2, or 4, 9, 12, 2, 8, 10. And so we can then, write that data to the file and have it go as long as we like. So that's the basics of writing to a file. There is some more functions here and there that we can go over, and I might make some videos in the future on that. But this video is basically just an introduction to file IO. So I'll just leave it there for output to a file. Now, in terms of doing some input from a file, let's say that I've got this content in my file now, and let's say I want to read from the file. Let's say I want to read data from the file. So to do that, we're also going to open a file. So we're also going to have a file handle, and we'll open a file this time for reading. And we're going to read from the file using a different set of functions. So I'm going to say here file, and I'll say *fh input. And I'm going to say here fh input is equal to fopen io.txt, open it for reading. And then what we're going to do is we're going to read from the file. And the way I'm going to do that is I'm going to say fscanf. I'll say fscanf, and I'm going to say fh, oops, I got a string there, fh input, %d, and then I'm going to say and I've got to put some variable here. I've got to store it in a variable, just like I would if I was using regular scanf. So I'm going to say here int f input is equal to 0, and I'm going to store the data in f input. So in the same way, fprintf is a lot like printf, just with a file handle here, basically, for the file you want to print to. Fscanf is basically the same as scanf. It's just that we give a file handle here for the file that we want to scan data from. And what I'm going to do is I'm just going to read in the first integer in the file. So I'm just going to read in the first integer that I encounter in the file. And then we will print it out. So I'll say printf, and I'll say like number, %d, and we'll output the number that we input there. And again, as before, we have to close the file handle when we're done with it as a best practice. So this will then open io.txt. It's going to set this f input to 0. It's going to use fscanf to read in the first integer found in that file, and it's going to store the result into the f input variable. And then we're going to print it out, and we're going to see it, and then I'm going to close the file. So we'll give this a try here. I'll say clear, and we'll do a recompile. We run it. So enter some data. So I'll say here like 10, then I'll say -1. So there's going to be a 10 in our file there. And then it says number 10. And so what's happened there is we've written to our io.txt file the integer 10, and this code here now has opened that file again, but this time for reading. And we use fscanf, and we read in that integer from the file. Now, one of the things we'd like to do is we'd like to ideally read content from the file until we reach the end of the file. So when we process a file, it's basically a stream of characters. And one of the ways we can read in that stream of characters is if we know the format of it. If it's going to follow a sort of specific format, fscanf can be a tool that's good for doing that. And the way fscanf works is it'll eventually return, if it can't read anymore, it'll eventually return this special constant EOF for end of file. And so scanf will actually return end of file when the end of file is reached. And so one of the things we can do is we can repeatedly call scanf until it returns end of file. And we can just repeatedly store whatever scanf gives us in a variable or in an array or however we want to store it. So I'll show you an example of what I mean here. So I'm going to actually now have a array here, numbers, that can store up to 100 int numbers. And I'm going to keep track of how many lines I've read in. And I'm going to now have some code here where I'm going to say here, while I'm going to say fscanf read in an integer does not equal end of file. So I know this looks a little weird here because we have an fscanf here inside of the condition of a while loop. But what's going to happen with fscanf is the same thing as before. It's going to read in from this input file here an integer. and it's going to store the result in F input. Now it's going to stop when it hits a new line. Same thing as Scanf. Like when you hit enter, it stops reading. Same idea here. When it hits the new line, it's going to stop. And then the next time we run Fscanf, it's going to read in the next integer on the next line. And what's going to happen is eventually Fscanf is going to be called to read the file, and it will have reached the end of the file. At that point, it's going to return this special constant value here, EOF, for end of file. And that's when we know we're done reading the file. And so what I'll do first is I'll just output the numbers here. I'll just output the numbers here first, and then I'll show you how to store it in the array next. But let's just see what I mean with this first, because I know this stuff is a little tricky if you're just learning this stuff. So we're going to say here like 2, 3, 4, 5, 6, and then I'm going to say -1. And we get here number 2, 3, 4, 5, 6. And if you look at our file here, that's what we've got in it. We've got like 2, 3, 4, 5, 6 in it. So what's going on here is that we're repeatedly calling scanf in this loop. And scanf is going to keep on reading the next integer until it encounters a new line, and it encounters a new line each time, right? Because it's just number, new line, number, new line, number, new line. So that's all there is to it. And it just reads in the number, and we store it into F input. And then once scanf reaches the end of the file, it's going to go to read the file, and it's going to basically say, I can't. We've reached the end of the file. It returns end of file. And then that's when we're detecting that we're done with the file. So if our file follows a well-known convention, like it has a well-known format, like it has, an integer on each line or something like that, or maybe like one integer followed by one integer on each line, then Fscanf can be a good way to read in that file. And what we could do is we could store that data maybe into an array. So what I'll do is I'll say here, let's actually store the data we've read into an array. I'm going to say here, numbers at lines is equal to F input. And I'm going to increment lines. And lines is basically going to keep track of how many numbers we've read in. And numbers here acts like a buffer in the sense that it can hold up to 100 numbers. We don't know how many numbers our file actually has in it, but we've made this buffer here that can hold up to 100 numbers, this array that can hold up to 100 numbers. When we use an array like this, sometimes we call it a buffer or an input buffer. And when I say lines equal to 0 here, what I'm doing is I'm keeping track of with lines how many lines I've read in so far. Because that lets me know where do I put it into the array next? Like what position in the array do I put the next line, the next number that I've read in? And I know based on lines because I'm going to increment it each time through the loop. And I'll output here, I'll say like file line %d, and I'll output lines each time. I'll say like lines +1. I'll output lines +1 each time. So I know which line of the file we've read in. So we'll try this now. We'll recompile this. We'll run this, and I'll say here like 1, 2, 3, 4, 5, 6, 7, 8, and I'll say -1. And then I get file line 1, 1, we get 1, 2, 3, 4, 5, 6, 7, 8, basically, right? We can try some different numbers now. I could say like 99, or I'll say 99. I'll say like 120, 12, 45, 56, or 67, 99, and then I'll quit. Okay, so we got 99, 12, 45, 67, 99. So, we read in those numbers correctly there. 12, 45, 67, 99, and yeah. And so, yeah, we've got the ability now to read these numbers from the file there. And we could do stuff with the numbers after. So I could do something like maybe compute the average of the numbers in the array. So I could say here like 4 int I is equal to 0, I is less than lines, I ++. And we could do something like compute the average. So I'll actually total up the numbers in our numbers array there. And then I'll do a printf, and I'll just compute the average then of the numbers that I read in. So I'll say like the average is going to be the total divided by the lines. And what I'm doing here is I'm going through this numbers array. I'm adding to the total here each time that starts at 0, the value of the number at the index I. And we're going to take I from 0 up until the number of lines. So this will go through all the numbers in the array, total them up, and then we're going to compute the average of the numbers in that array, and we'll just output that to the user. So I could compile this here, and we'll run this, and I could say like, I don't know, we'll say 20, 50, 100, -1, and then we get here 20, 50, 100, we get an average of 56, and that makes sense. And so we can do things like that as well. Now there's other functions we could use to read things from the file. I don't want to go over all of them in this video just because it would just get too long, but there are other functions we could use. I'll show you one more, and we'll do another input. We'll do another open of the file here. So I'm going to say here, I'll say clear, and I'm going to say here fh input, and I'm going to open the file again. I'll say fopen, and I'm going to open a file called in.txt this time. And I'm going to open it for reading. And then I'll close the file after I'm done with it. So I'm just opening up a different file now using the same file handle after I've closed it previously. And I'm going to open up a different file here called in.txt for reading. And in.txt, I'm going to make in.txt store a bunch of different data. So when I say touch in.txt, that'll create the file. And then I'll open up with this VI here and I'll just say in.txt and I'll just throw some content in this file. So this is some random content in the file. Let's read it in using a different function called fgets. And we'll just write quit and we're going to save that file. Now, if we look at in.txt, it's got that big mess of text that I just put in there. And so this is just some random content in the file and we're going to read it in. And we're going to read it in with a different function now. So I'm going to use a function called fgets and I'm going to use fgets. Now fgets, the way this one works is it takes in 3 arguments. It takes in a buffer, like a character buffer or character array to read in the data. So I'm going to say here car buffer. We could call this anything, but I'm going to call it buffer because that's what I'm using it as. And what it is it's just a character array. And it's a character array that's going to hold up to 256 characters. Then I'm going to say here buffer, and I'll say 256, and I'm going to say fh input. So the 3 arguments it takes in is the array to write the input to, and this will not write to the array here as anything but strings. So it's going to read the file as a string. So if there were numbers in there, this approach will not read them in as like an integer or something like that, like Fscanf will. This will just read in the file to this character array as the characters that it is. And then this second argument here is basically the size of the buffer. And it's basically saying don't go beyond this size because that's all it can hold. And then this here is the file handle of the file that we're going to read from. And then I could say here like printf, and I could say buffer %s, and we're going to output whatever we've read into the buffer. And what it does, fgets, is it reads in the content of the file as a string, and it stores it into buffer as a string up until this number here. And this is a typical way to read in files, is just to have some large input buffer here, some large character buffer here, and then you just use fgets to read in that file. Now, the way that fgets works is if it reaches the end of file, it's going to stop, and if it reaches a new line, it's going to stop, and it's going to read the contents of that line into buffer. And so you'd have to call fgets potentially repeatedly to read in the entire file. In this case, though, I've actually only got 1 line. I only put in like 1 new line at the end, really. So it should actually read the entire string into the buffer in this case. So I spelled fclose wrong. That's why that's highlighted there. Okay, so we'll clear this and we're going to try running this now. So we'll compile it here. We'll run this here. It's going to ask us for some data. I'll say 1, 2, 3. -1 to quit. I get lines 1, 2, 3, average of 2. That makes sense. And for my buffer, it says this is some random content in the file. Let's read it in using a different function called fgets. And we just did, right? Because that was the content in our in.txt file. This time we just read it in as a string and stored it into buffer using fgets, which is just another way of getting data from a file. And there are some other functions to get data from a file as well, but for an introduction to file IO, we've actually covered quite a bit. So I'm actually going to leave it here. And hopefully this is giving you a great introduction to file input and output with C. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.